coming out for a brown bag today, and I had some last-minute inspiration. So we're going to go ahead, we're going to kind of mix things up a little bit here. I was thinking to myself, what could I do to really just add some innovation and, change things up a little bit for my brown bag? And I'm thinking to myself, Ted, what can I do? What can I do? I'm going to be doing some talking. And then it all clicked. So here we go. Prepare for TEDx Piraeus. Today we're going to be talking about vision, execution, and synergy. I want you to embrace your inner. This is going to be key. All right. In all seriousness, today we're going to be talking about a topic that is near and dear to my heart, that waking up in the morning gives me joy. Single performance. That was actually serious. I really do enjoy this. It's a fairly technical subject for a brown bag, but I tried to hit this at a few different levels. I tried to hit high-level summaries as well as diving really deep. Questions are awesome. If you want me to pause, jump up, throw a hand, just say, hey, what are you talking about there? And I'll try and clarify. This is a huge, huge topic, and there is no way that I'm going to be able to cover it all. What I'm going to try and do is hit several simple techniques that are going to work in almost every situation. And if you don't remember anything else from my presentation, remember this. Don't panic. There you go. SQL performance tuning may seem like a black art at first, but if you just are persistent, don't give up, you'll get it. So let's dive in.
All right.
So let's start by setting the stage. It's every database nerd's nightmare. Friday afternoon, you're ready to go home. All of a sudden, you get that email, you get that call. Something really important isn't running as fast or isn't running the way it should be. P0 escalation. This is where your blood pressure starts kicking up. You need to solve the problem. You need to make it run faster, and you need to do that right now. So where to start? First thing to remember is, what is SQL's job? Let's step back and see the problem. At the end of the day, SQL's job is basically about finding bits spread out across hard drives and then turning around and writing other bits to those same hard drives. Finding a needle in a haystack would be pretty easy by comparison. So in the vast majority of slow queries I run into, the bottleneck that we're dealing with is a hard drive. And hard drives are by far the slowest part of a modern computer system. SQL's got lots of cool tricks to help mask how slow hard drives are, but they can only do so much. So, I said this a minute ago, but I'm going to say it again. Hard drives are the slowest part of a modern computer system. You can't really understand how slow hard drives are until you compare them to flash memory, like what you've got on your phone. Here's some charts. These are comparing solid-state disk and one of the fastest hard drives on the market. Best case scenario, the hard drive is twice as slow as the solid-state disk. Worst case scenario, the hard drive is 150 times slower. So, seriously, hard drives are really, really slow. Really slow. You can use technologies like RAID, where you take multiple hard drives and have them all work simultaneously. That can help quite a bit. But at the end of the day, I/O is typically the biggest bottleneck in a modern data warehouse. So, keeping the last slides in mind, how do you solve the problem? Option number one, pull out your checkbook, write a really big check. Problem solved, piece of cake, right? Just buy lots of solid-state disks, lots of RAM, throw SQL 2014 on there, which is particularly well suited to take advantage of that RAM. Call it a day. So what's the catch? Seems too easy, right? SSDs are still an order of magnitude more expensive than hard drives. So what that means is that back in the real world, where we are, and money doesn't grow on trees, we've got to work with what we've got. So to make SQL go faster, we've got to first figure out where the problem specifically is. Then let's look at solving the problem. Finally, let's make sure we don't run into that problem again. There's nothing better than putting a little bit of work into something ahead of time to save yourself that stressful Friday afternoon call. So let's start by finding the problem. You've got your cranky client breathing down your neck. Your first instinct, you've got some pressure, it's starting to hit. You want to start changing something, you want to start doing something. Resist that impact. Resist that instinct. Just step back. You want to understand first where the problem is. Is it something that was changed? What changed? Is it something that came in with some new code? Is it some old code that accidentally got brought back? You can speculate all you want, but until you really know what specific code is running, you're still guessing. So one important, easy step is to take a look at the server. Remote in, take a look at Task Manager, Control-Alt-Delete on a local PC, and see what it's looking like. And this is where an ounce of prevention can really help down the road. Take a look at your server before there's some problems. Understand what it normally looks like. Have a good idea so when you are running into problems, you've got a good baseline to compare it to. So every server looks different. It's not unusual to see SQL gobbling up all the RAM. Yeah, that's pretty normal. Typically you'll see mid-range amounts of CPU being used. A lot of times when you're seeing problems, though, it's going to be your disk usage. You're going to see that just a peg. And we'll take a look at that again here in a moment. Another thing to check, what else have you got running? Is there a job that you weren't noticing that's conflicting or that's dragging the whole thing down? Take a look at SQL Agent. Can you stop any of these other jobs if you've got multiple jobs running at once? Take a look at your logs. Do your queries have logging implemented? Take a look at that. Take a look at the last code that was run to see where the problem might be so you can pinpoint it. And then, if you've done all that, bring out the big guns. So we'll talk about SPHOO2 here in a minute. So this is an actual task manager session from this week on our dev server. I was doing some troubleshooting. And as you can see, we're at about 97% memory utilization. Yeah, that's pretty normal for that server. This is actually pretty high CPU utilization for that server. That was when it was just really cranking through. But as you can see, we've still got plenty of CPU headroom there. To me, it does not look like the problem is related to the CPU. So this is where we want to dive in one step further. Let's take a look at SPHOO2. And SPHOO2's job is to return a list of all queries that are running in the database, along with some information about them. It's really easy to run. This is it right here. Just run the command sp_who2. Justin and I were looking at it just a little bit earlier today. That will show you what's currently running. And then after you've done that, we can use the dbcc input buffer to get the specific SQL code that's running for a given process. And then if you need to rain fiery death down upon one of these misbehaving queries, use the kill command, unsurprisingly, to kill it. Let's take a look at how this actually comes through. So here's an example of what SPHOO2 actually looks like. I took this screenshot again this week when we were running into some problems with query number 67 down here. Now the first thing to take a look at is, do you have anything in the block by column? Notice we've got process 67 is being blocked by 61. So that means we need to take a look at what's going on with 61. In this case, 61 had legitimately just crashed. We needed to kill that. At that point, everything was fine. 67 that we were originally concerned about was able to complete just fine. That's probably the easiest case scenario. Let's take a look at one that's a little bit messier. So this time we're taking a look at number 78. Notice it starts here at the top and we've got multiple 78s all the way down toward the bottom. In this scenario, SQL's done an awesome job. It's split up the query to take advantage of all those processors that we've got. But what's ended up happening here, notice we've got only one of these in a runnable status, tons of CPU time on that one, lots of disk I/O there. All these other queries are just sitting waiting. They're all bottlenecked, waiting for access to the disk to take their turn to write that out. So let's go ahead and talk a little bit more here. So SPHOO2 has confirmed we've likely got a hard drive bottleneck. So again, before you dive in to start changing your queries, think about your environment. Is everything configured optimally? Check to make sure that you've done everything possible to spread your I/O across multiple hard drives. Are you following best practices regarding SQL? Do you have your logs separated from your data files? One option that may be worth pursuing if you've got this is look at reconfiguring your RAID levels. RAID 10 is the king of RAID levels. It trades capacity for speed. Not an option in all cases, but certainly something that if you do have that option available, worth taking a look at. So we should, by this point, have a generally pretty good idea of where the problem's coming in. SPHOO2 can give you a lot of information, looking at your server environment, understanding your configuration. Let's dive in and actually solve the problem. So we're going to start chopping some code apart. Now the question is, wouldn't it be cool if SQL had a tool that would let you see precisely how it's planning to execute your query and where any bottlenecks are? Andrew, does that sound like a pretty cool thing? Don't you wish that SQL had a tool like that?
Absolutely.
You know what? Your prayers have been answered, my friend, because there is the estimated query execution plan. And this little bit quirky of a tool. And what it's going to do is it's going to take your query and break it up into the underlying pieces that SQL is going to use for its actual execution. It's going to rewrite this to be more optimal. And it's going to estimate how much each code segment is going to cost relative to the other pieces. And this lets you pinpoint the exact part of your query that's causing the specific pain. So we're going to take a deeper dive into this in a minute. Here's a quick screenshot. One thing that's kind of screwy about this tool, when you're reviewing it, you actually have to start at the bottom right and read toward the top left, which is exactly opposite of how everything else in this world is read. Somebody who's up at Microsoft asked one of the engineers why they did it this way and if they could, change it up. But one thing to watch for, in particular, are table scans, and I've highlighted one down there. Those are perhaps the single most painful operation that your query can run into. And basically, in that scenario, SQL is having to scan through an entire table to find the particular pieces of information you're looking for. Our goal, we want to change that to another type of operation, typically using an index. And that is where I want to talk about indexes for a minute. Now, indexes are kind of scary at first. Let's make them really simple. So I need an assistant. Andrew, would you volunteer to be my assistant here for a moment? Been a good sport so far. Come on up. Right up here. So Andrew, here is a book for you. We're going to pretend that Andrew is our database server. Good job, database server Andrew. We've just told Andrew that we want to find every sentence that has the word cat in it. So Andrew, as a database server,
got it.
You think, okay, you can do this. Andrew is a particularly fast reader. He's going to start at page 1. Go ahead and open that up here. Start at page 1. Any words that have cat in them there? Okay, not saying, okay, go on to page 2. And this is kind of a silly example, but this is in a lot of ways very similar to a table scan. You're asking the database to go through and read every single page of information to look for the data that you are interested in. Andrew's doing pretty good. He's up to page 8 here, it looks like. So let's talk about using an index instead. Okay, Andrew, great job, thank you.
Sorry.
Oh, you're not done yet.
Oh.
So we've now given Andrew an index. So in this example, Andrew can open up the index and he can search through the index. And you'll notice right there, here is the word cat, and along with the index, it shows along with that word in the index, it shows exactly what pages he needs to go and look at. So that says to look at page 642. We're going to go straight to page 642, right there. The next one said page 427, right there. It's a silly example, but this is really, this is actually very similar to how an index works in a database environment. Actually, we are done now. Thank you very much, Andrew. Appreciate your help. Let's all give Andrew just a quick round of applause. So the bottom line is that indexes can make everything a lot faster when you're trying to find the needle in the haystack. And we want to, as much as possible, give SQL what it needs so it can avoid those table scans, so that it can avoid having to go all the way back to the hard drives and pull through all that information and find what it's looking for. So let's go ahead and switch out here for just a moment. Let's go to an actual query. I stole this from a work item that I've been doing. Okay, here we go. Now the first thing, notice that SQL very helpfully puts up there is that we are missing an index. You may or may not get a message like this when you run the estimated execution plan. If you do, pay attention to it. That is probably the single best thing that you can do to try really fast to make your performance better.
You can get to the create code.
It does, and you can right click on that and you can see missing index details, and it will script it out, pretty much ready to go. You select that, you hit execute, you're done. It's an awesome tool. Now, that doesn't happen all ways. I use this example so I can show that. A lot of times you pull it up, it doesn't have a very specific impact. Excuse me, a missing index that would give you the most impact. So let's go ahead and scroll all the way down to the bottom right, and let's work through this. And notice for each of these we have cost highlighted. This one's cost is 18%, this one is 2%. What you're wanting to look for are the ones with the highest cost. And in this case, we can see that it's also a table scan, and it's 18%. That seems like a pretty good part of the query to focus on. And let's just kind of move over here. Notice this doesn't look anything like our original query. This is what SQL has rewritten it for to try and run it with optimal performance. Notice up here we've got some clustered index scans. This is where SQL is able to take advantage of indexes that we've got to much more quickly bring the information out. So let's go ahead and talk a little bit more about indexes because they're really important. SQL's got 3 types of indexes. Start with clustered, move on to non-clustered, and then in scenarios where you've got a really tough nut to crack and you're using either SQL 2012 or 2014, take a look at column store indexes. Key thing I want to call out about indexes is that they add overhead. Going back to our book example, every time, pretend we're still writing this book, and every time we add a page, we would need to then update the corresponding piece to the index. Same thing with SQL. When you're adding new data to a table, you have to make sure that your indexes are staying up to date. So indexes do add a bit of overhead for inserts and updates. The trade-off, they can really help your select operations make things much quicker. And then, let me ask another rhetorical question here. Since we've got a lot of pieces moving around here, wouldn't it be cool if SQL had a tool that could recommend exactly which indexes would be most helpful for a given query? Does that sound pretty cool, Ken? Yeah, it totally does. So let's move on to the Database Tuning Advisor. And this is another one of those, only from Redmond, a little bit quirky tools that is awesome, but has a little bit of a learning curve. So this picks up where the estimated execution plan leaves off. And I will demonstrate that here. Here is that example that we were looking at a moment ago. And what I have done is I have gone to the query menu and chosen Analyze Query and Database Engine Tuning Advisor. And that will bring up the screen that I was just showing you a moment ago, and I'll actually pull that up here. So look, something like this. And the way that you work through this tool is that you move through the tabs across the top of the screen. It's not terribly intuitive if you've never used it before. A key step not to forget is that you will need to manually choose which databases your query uses. If you forget that, you're going to get much poorer recommendations. I've gone ahead and already run that here in the interest of time. You can choose how long to let this tool run. Typically, if you're in a hurry, give it about 5 minutes. The default is to let the tool run for an hour. That trips folks up quite a bit when you're getting started with it. While it is running, it'll look something like this. Once it finishes up, it'll give you a screen that looks like this. And another thing to watch out for here is notice the scroll bar on the bottom. There's more to the right, and I've seen people get really confused when they're using smaller screens or lower resolution monitors. What we have here are the recommendations along with the estimated improvement. In this case, SQL is thinking it can improve things by about 7%. That's not super great, but that may be worth following up on. If you scroll to the right, you can see the actual code that SQL is recommending we run. Let's go ahead and just pick on this bottom one. And that will bring up the code to create the index that it thinks would be most optimal in this scenario. You can choose copy to clipboard, drop that back into SQL Management Studio, run it, and then hopefully, again, move on with your day. So Database Tuning Advisor is another really great tool. Again, a little bit quirky, but very helpful for purposes of keeping things fast. So let me go ahead and switch back to the slide deck. So we've done quite a bit from a system standpoint, but there's only so far that you can go sometimes. If you hit a point where adding indexes isn't going to help, or you don't have any systematic problems, it's time to dive into the code and start thinking about restructuring. And this is where, if all of you read Richard's blog posts this week, dealing with temp tables, taking a divide and conquer process can be really helpful. What you're going for at a high level is taking big complex queries, breaking them up into smaller, easier to digest queries. We want to keep every step as simple as possible. That means trimming all the fat, get rid of all the columns that you're not needing. If you can, pre-filter your data, and we'll walk through what that actually looks like. So here is a query that has some problems. It's not running fast. We've got Some obvious things that jump out here, we've got a lot of select stars. Anytime you see select stars, there is potentially an area for optimization. This one I have made to be intentionally bad, but this is not too far off from some very real-world queries that I've seen. Along with that, we've got multiple nested sub-selects. So we've got complexity both from a system standpoint as well as from an understanding standpoint. And there's no comments, which it's not going to make it slower to run, but it's going to make it harder for us to troubleshoot. And to make things even worse, all this complexity is masking a problem. There's a bug hiding in this code. We've got one of these tables joined in for no reason. There's no benefit to it. But because of how this has been written, it's difficult to see that. So here's what that looks like if we were to rewrite that using temp tables instead. The first thing we did in step number 1 was narrow it down to just the 2 columns that we actually needed. We've taken potentially a very wide set of data and made it much skinnier. So we're pulling fewer columns of data back from the slow hard drives. We've also gone and we've pre-filtered. So every step that's relying on this data is only dealing with the data we actually care about, everything past January 1, 2013. In step 2, we've taken the results from step number 1, now filtered, trimmed down quite a bit. We've joined that in. We've done some additional filtering here. Again, at each step, keeping things fairly simple, fairly straightforward. This is a lot easier to then troubleshoot. You can see exactly how long it takes to run each of these steps to understand even more where you need to focus on cleaning things up. And then at the end, we pulled it all together, again, using the pre-filtered results from the previous 2 steps. I would suggest if you're interested in reading more about this, take a look at Richard's blog post. He did a great job of going more in depth here. This really does work.
Can I ask you a question?
Yeah, go for it.
The temp tables, that's writing to the disk, right?
It is writing to the disk.
Slow disk. So
Yeah.
you're writing a big select statement to the disk. Is that going to slow that down versus pulling it all into the nested tables and into memory?
In this scenario, you are going to be better off overall. Let me jump back to the previous example here. In this case, and I'm going to gloss a little bit over the technical details. We can follow up afterward. What SQL is trying to do is it's trying to read in and do joins from several really big tables all at once. And if you've got scenarios where you're bringing in a lot of columns, that can, to gloss it over a bit, it can overwhelm the server. And then in this case, yes, even though in this case you are writing this temp table to disk, you're writing a much smaller set of data. And then all of the operations past that point are able to use this small set of data rather than the original very large, very deep set of data. So it may seem counterintuitive. Yes, you are going to spend a little bit more time writing to the disk up front, but overall, your query from the big picture total time standpoint is going to run much faster. So great question. I'd love to follow up with you on that more afterward. So this one goes against regular best practices, but once again, I have yet to meet a Microsoft product that doesn't work better after reboot. So regularly scheduled reboots do help. And then the last piece, as we wrap up here, try going forward. You've solved the problem, you're done for the day, but keep in mind, wouldn't it have been even better if we didn't have this problem to begin with? What can you do to avoid the problem next time? So here's a couple design patterns and things to keep in mind. Database maintenance, it's not fun, it's not glamorous, sometimes can seem very complex. It doesn't have to be, but it can also really help as you're thinking about overall system performance. We've got some great, easy, award-winning maintenance plans you can download. This gentleman puts them together, you can install them, get them up and running in less time than I've been up here talking. Regular reboots that we talked about. And then also understanding SQL memory allocation. In the interest of time, I would just say this is really important, but not something we're going to be able to tackle here. Make sure when you're setting up your server for the first time that you really understand how you're allocating memory. That can be really important for the long-term health and speed of your queries. We talked about this in the troubleshooting process. Here it is generally again. Think about using these type of divide and conquer approaches, not just for a performance duty standpoint, but for a development best practice. It tends to help you as you're designing and building. I can't count the number of times I've been midway through a very complex query and somebody comes over, taps you on the shoulder. You get a phone call, you get an email, you lose the thread of where you're at, you're out of the moment, and it takes you several minutes to get back up. One of the things that the divide and conquer approach allows you to do is to have a lot smaller chunks of complexity, so it's easier to step back in, and overall it does, in my experience, tend to help you write code faster as well.
I guess
Go
to
ahead.
that point, Tim, maybe
Yeah.
it's just important to know if performance was really an issue and you're trying to squeeze as much out of it as possible, then maybe, but I think most of the time, having something, code that's readable and observable, like what you just said, sometimes overrides having to squeeze every ounce of performance.
Very wise. Did everybody hear what Todd was saying there? I mean, I can't underline this enough. Being able to come into a new environment, as sometimes we do, and be able to get up to speed quickly, solve the problems quickly. Sometimes that little bit of extra time that you spend putting the few extra comments or designing it just a little bit more cleanly, that can make the world of difference to the next developer that comes along.
And I was thinking like the example you showed where, you have to use temp tables and because you can componentize it. And
Yeah.
Like you were saying about, it's just easy to know where to go if there's a problem potentially.
Exactly. Thank you for that, Todd. We'll go ahead and wrap it up. Again, for those who are just waking up, here it all is. The entire thing. If you can afford it, RAM and SSDs are awesome. Talk to Ken or whoever your boss is. Say, hey, I need a big check, and make that happen. Take a look at your long, complex queries. What can you do to, like we've been talking about here, make them simpler or componentize them down to smaller pieces? Database Tuning Advisor, remember this. It can really save your bacon. When you're stuck, you don't know where to go next, let it take a crack at it, see if it can help out. So, thank you all. Appreciate it. Go ahead and wrap up.